看中奖，他不用啊。那这个。
Alright guys, this tutorial is on one sample test, right? So these are the formulas you will need to use. These are all the formulas you need to use to do this tutorial sheet. Right, so can you start with question 1 please? So these are the formulas. We learned them in the week before the Easter break. There's no need to copy or scan. give you a couple of minutes to do question one. Guys, if you've done quiz 10, can you can give it to me now? You've already done quiz number 10. Thank you very much. Anyone else wants to handle quiz 10? You okay? Alright guys, let me show you how to do question 1. Which you haven't done it yet. Okay, so now let me ask you, there are three kinds of things here. Testing for population mean when variance is known, testing for population mean when the variance is unknown, and testing for population proportion. Now question 1 falls under which of these three? Is it this one or this one or this one? First one, right? Okay, so let's do it then. So you're testing So what is the rule? So in this case, the rule for rejecting the null hypothesis will be what? If you look at the rules here, these are the rules, right? The rules for rejecting the null hypothesis will be root of n, which is root of 40, divided by sigma, which is 30, times x bar minus mu 0, which is 200, greater than z alpha. So z 1 minus alpha by 2. Okay, so this is the rule for rejecting the null hypothesis. Now, if there are two values for alpha, so in the case alpha is 0.05, you should take alpha to be 0.05. This would be the same as yeah, and this would be now. Can somebody read this for me? It's 0.975. I told you last time how to read tables, right? What is this one? It will be, I think it will be 1.96. Correct me if I'm wrong. You should read that off the table. I know. Is it 1.96? Okay. Now, if alpha is, correct me if I'm wrong. You said what? I may be wrong. I don't know. If alpha is 0.01, right? Then this would be Can somebody read this for me, please? I don't have it. I have the table here somewhere, but let me check. So this is the table here. Do you guys have copies of this? No. You have? You don't have? Yuncheng, can you come up here? Can you distribute this? If you don't have a copy, just my colleague will give you a copy. Is it copies of the table? So you should read it. You should read 0.995. $2.575. 2.575. Okay, so that's question 1. Can you do question 2, please, now? Can you move to question 2, please? So everybody got a copy? The table. Can you guys do question 2 now, please? Question 2. I put the table. So I put the formulas back on. So these are the formulas back on. So try. Anybody who hasn't signed the assignment sheet? Anyone else, guys? Anyone else who hasn't signed? You have signed? No. Thank you, guys. Right. You have to remember that only one of them. If you look at the formula sheet, if you look at the formula sheet, it is dash.
Does it have 35?
No, only one page. Only one page. Come on. This one, this one here. You only need to remember. You only need to remember. The first column. So you need to remember the first column. No, it may be tested, but in that case it will be given. I mean, the formulas will be given. So you need to remember the first column. But how? You okay, man? You look bored. You guys done question 2, guys? Yes, we have a question. Which one?
For number 1, part 2.
I haven't done it because it's similar. I mean, it's similar, so I haven't done it. It's past 2.
That's X bar, which is mean is 200, isn't it? It's 200.
Yeah, mu 0 will be 200, yeah.
So that'll be 200 minus 300, which is
No, not X bar. The mu 0 is 200. X bar is not given in question 1.
So we just list out it.
Huh?
We just list out it and then leave it.
Yeah.
Right.
Yeah. I mean, in question 1, guys, only what you are given is mu 0. There is no value. You are not given any value for. You are not given any value for X bar. So you have to leave X bar as X bar in question 1. Okay. Now let's see how we can do question 2. Oh, where's my pen? So you have, you're testing, let's look at part 1 first. You're testing mu equal to 0 versus mu greater than 0, right? And you're told that n is 10 and sigma squared is 3 and your alpha is 5%, so 0.05. Okay? So what's the rejection rule in this case? Can you tell me? I mean, but first of all, which column will it belong to? Will it belong to the first column or the second column or the third column? Which one? First column. So you reject H0 if root of n, which is root of 10, divided by sigma, which is root of 3, times x bar minus mu 0, which is 0, greater than z 1 minus alpha, which is 0.95. Alright, so this is the rejection rule, which of course you can simplify to the following. And if you read this off the table, it will be 1.645. Alright, correct me if I'm wrong. So that's part 1. Part 2 is to calculate the probability of type 2 if, okay. So we want to find the probability of type 2 error. If the true value for mu is 1, so that's the probability of accepting H0 when mu is equal to 1. So in other words, this is the probability that right, now this is why you need to use the right, I'm going to show you in a minute what I think I mentioned this a couple of times in the class. You see, what I've done here is to subtract 1 and add 1, and the reason I'm doing this is because the true population mean is 1, right, not 0, right? Okay. Right. Now, I don't know whether you remember, guys. I think I mentioned this in the lectures at least 2 times. I don't know whether you remember that the following result, that if you have a random sample from a normal distribution, right, then the following result is true. That is, x bar has a normal distribution but these parameters. So in other words, which is the same as saying that root of n divided by sigma times x bar minus mu has a standard normal distribution. So I'm going to put this in a box. I'm going to put this in a box, and using this box, because the true population mean is 1, using this result we can argue that this guy here is standard normal. So okay. Alright, and finally you can write this as phi. Phi is the CDF of standard normal at 1.645 minus the square root of 10 by 3. So that complete. This is part 2 of question. Part 2 of question 2. Part 3 is trivial, so just ignore part 3. So can you move on to question 3, please? Now, question 3. Is it, by the way, is this clear to all of you now? I mean, I've done questions like this in the lectures, you may remember. Or no? Yes. You guys okay with this? Yeah. I know. You guys okay with that? Or not? Yeah. Alright, can you do 3 please? Question 3 now. I'll put the formula sheet back on. So this is the formula sheet you need to use. Try question 3 please. Okay. Matt, this should be 1 minus alpha, sorry guys. This is 1, it should be 1 minus alpha, 1 minus alpha, hold on. It's just a typing error guys. So it should be 1 minus alpha, 1 minus alpha. Okay. I think you probably noticed that anyway. This guy and this guy should be 1 minus alpha, right? As it was in other places also. So this, yeah. Have you guys done question 3 yet? Alright, let me show you. Right? It's not difficult. Alright. So you're testing for yeah, and your n is 250. Your x bar is 1794.6, and your sample variance is s squared is 2484, and your alpha is 0.045. So in this case we reject H0 if what? Which rule are you going to use? The first or the second column? Why first row? So in this case you are given a specific sample, and you are given, based on the sample you have a sample mean and a sample variance. So the population variance is not assumed to be known, so you should be using second column. Okay? You follow what I'm saying? So you reject H0 if root of n, which is root of 250, divided by s is the square root of 2484, right, times x bar, which is 1794.6, minus mu 0, which is 1800, is greater than t n minus 1, which is 249. 1 minus alpha by 2 is 0.975. Now this is where you need to use the t table. It is in front of you. If you look at the t table, this is the t table, right? So you look for 0.975 is this one, right? And you go down this, you go down this column to until there's no 249 here. All right? There's no 249. So you look for the value which is closest to 249, which is 100. So you pick up this one. You understand? You understand? I mean, the value that is closest to 249 in this column here is 100. The corresponding value is 1.984. So this is equal to 1.984. Right? Okay, so now if you have a calculator, you can work this out and see if it is greater than this. Okay? Alright, that's question 3, guys. Now, can you move to question 7, please? Question 7. Are you guys okay with this or not? Yes? No? Are you okay with this? Come on, guys, talk to me. Yes? Yeah. Alright, can you do question 7, please, now? 7. Yes. The sample mean is given in this question. The last one, it wasn't given. What? Yeah, but yeah, you could put substitutions in the last one. Yeah, I just forgot to do that. Yeah, I just forgot to put the sample name here. Yes. Yeah, you substitute here. Let me put the formula sheet back on. Where's the formula sheet? Question 7, guys, please. Can you try finishing question 7, please? Did you go to the
Yeah.
There's no table for last month. I think there's a table for last month. Yeah, use the normal table, yeah. For the last month. We converted you can take the log and then look for the normal table. We are doing question 7. You guys done 7, guys? No, not yet. Alright, let's see how we can do better math. This is question 3. The next one is question 7. Right, now what is the, can you tell me what the rejection rule is? Hello guys, what's the rejection rule in this case? If n is 400, x bar is this. C0 is 0.1, should be greater than z alpha. Alpha is 5%, so 1 minus alpha by 2 is 1 minus 0.05 divided by 2, right, which is am I right? Alpha is what? So 5%.
Yes.
So it's 0.975. Can somebody read this for me? What is 0.975? 1.96. Okay. Alright, so that's it. So you work this out and compare it with 1.96. So if this is greater than this, then you reject, otherwise you don't. That's it. So that's part 1. Are you guys okay with this? Now part 2 is to find the probability of rejecting when the true value of p is what? You know how to do that, right? Or do I need to tell you how to do it? It's not, I mean, so this is part 1. Part 2, this is part 1. Part 2, question 7, part 2 is like this. You want to find the probability of reject H0 when the true value for P is 0.103. Okay. So basically what you need to do is you need to find the probability of oh sorry, I missed out a square root. There's a square root missing. There should be a square root here which I left out. There should be a square root at the top here, right? Okay, so this is what you need to find. You need to find the probability that this is greater than 1.96, given that the true value for P is 0.103. Okay, so what you need to do is basically you need to change the 0.1 here to 0.103, right? So how do you do that? You have ideas? Come on, guys. I'm sure you know how to do this. The first thing you must do is to remove the absolute sign. So it's 47 minus 400. Okay, it's either greater than 1.96, right? Okay, given or is less than, the whole thing is this whole thing, right, is less than minus 1.96. When I say this, I mean this thing copied over here, right? Okay, that means this whole thing here copied to here, right? Because when you remove the absolute sign, it means that either this is greater or less than minus 1.96, right? And then you okay, in this step I'm gonna change the 0.1 to 0.103. Okay, so what I have done is to subtract 0.003, right? So I need to do the same thing on the right hand side. 0.003 times given P equal to 0.103, and then plus, I know it's a lot of writing, guys, but it's not really difficult. This looks like a lot of writing, but it's not. Then the whole thing here is repeated. So this, what I mean by repeated is that this thing here should go to over here, right? Less than 1.96 minus 1.96 minus 0.003 square root of 400 divided by okay. Now in the final step, which I'm not going to do because of the time, final step, what you will do is to replace this by a standard normal variable, because according to the result I just mentioned a few slides ago, that this has a standard normal distribution, right? So you just replace this by n01 and here also n01, right? So try to complete it. I think we run out of time, so try to complete the last step by replacing this guy and this guy here by a standard normal random variable, right? That's all you need to do. Alright guys, I'll see you next week. If you have questions before that, come and see me. You know where to see me, or email me. Okay. Hello, sir. You're done?
Yeah.
All right. Have a good day, man. Take care. Hello. You have a question? Attendance. Yeah. Okay. Of course. Attendance. It doesn't matter, it's still a number. Yeah, it's still, expire is 47 divided by 400. That's fine. Yeah. It will still, the process will still be the same. Yeah, it will still be the same. Right, see. Hello guys, you alright? You okay? You guys going home or are you going home?
No, we have class.
You have a class now?
Yeah.
What class is that?
Computer science application.
Oh, is it easy or?
Very hard, I think.
Ah, come on.
My next novel.
应该有吧？现在都没有。给，good for you.